Okay. So I'm gonna have this at one, it's technically, well, let me see if that person's remote. He's in trouble, so technically there is somebody that sits here, the last one. And I literally have one more space now available in this class, but it's just, some people are remote and some aren't, so. All right, yes, I know some people still have questions with the balancing. Now, the paper that was from Friday, okay, the more balancing stuff. I'm looking for that today. Hold on. Everything is in Canvas, and y'all, shush, they're both right in. Boys, shh. So today, I just unscrewed it. Okay. Today, I'm going to teach you guys how to use what's called the activity series of metals chart. It's this thing on the side of the notes. It is really, now please put your phones away and stop eating in here. It is not really that difficult to use. You just don't know how to use it yet. And then tomorrow, I need to teach you how to use what's called the solubility chart. Okay, so today's assignment, and those of you that are online can't see me holding this up. This top part is really tomorrow's notes. Right, and put the phone away. This bottom part is really today's notes. Jeremiah, get your Chromebook out and put your phone away. I can't do all of it at once. It's too much. And I do know that some of you still have questions from the balancing. Y'all, your balancing test is Tuesday. I haven't seen it yet. Ms. Callan's normally the one that makes it. If we need to not do the lab that we're supposed to do Friday, and instead of really review you guys 2 days in a row, if that's what's necessary, that's what we'll do. I hate sacrificing stuff like that, like actually touching with things labs, but if that's what has to be done to make sure that you guys understand how to balance, you don't fail the test on Tuesday, that's what we'll do. So right now, we're going over this activity series, which is the 32 part 1, or I think it says 32A. And then, yes, it's 32A. Tomorrow we'll do the solubility chart, which is 32B. Let me unfreeze this. I've got, well, actually, no, let me get it out of the Brave. I've got somebody I need to show how to navigate my Canvas real quick. So those of you that are online, you're not going to see what I'm about to put up because you're only seeing the screen. I'm going to show you how my Canvas is organized in just a bit, George. It's because you put mine, you need to navigate it not on the dashboard, you need to use the module. But I'll show you in just a minute. Let me turn the light off and shut the door. Make sure that the heater's not going to turn off. So I keep in mind, I don't think there's going to be a test. We have 4 weeks, we have 7 weeks in the 6 weeks. And I'm pretty sure that grade cutoff is like the 26th. And that's the day of your test. So your average may only be a daily average because we haven't had a test yet. But we'll have at least one more paper test. And keep in mind your notebooks are still a test grade at the end of the 6 weeks anyways. This opener, we have to figure out what the missing thing is in the blank. This is a synthesis or an addition or a combination, however you want to say it, reaction. This is predict the rest of the following chemical reaction and identify the reaction type. Right? So zinc plus what is missing is going to produce zinc chloride. What is missing? Chlorine, okay? But you can write chlorine gas, but the problem is not necessarily figuring out what's missing. This part's the really easy part. It's doing the skeleton equation so we can balance it. I know those of you that are remote can't see my dry erase board, and even if I try to point my camera at it, it's at such a sharp angle that you can't read it anyway. So it should be zinc plus, and then the missing thing, this is chlorine gas. It's always a gas in its natural state. Okay, and it's going to make zinc chloride. I need to give you something real quick here. 2 things real quick, which are all linked in Canvas, but without them, I'm not really going to know what's going on. Unfortunately, when they spray my room, the papers curl. So we need a periodic table. Oh, that's not the right one. It's not the right one. We need a periodic table with the charges on it, the polyatomic ion chart. It's been a while. It's going to be a massive crash course trying to get this done. Now, all of this stuff is in Canvas. Openers are working daily grade, every progress report and report card. There's like a text box entry in Canvas. But we're going to write the skeleton. What's the symbol for zinc? What's the chemical? Zn. Okay, it is not one of those 7 special elements, so it's just Zn. What about chlorine gas?
Yeah.
It's 2 because there are 7 diatomic elements, which is something else that literally on your periodic table, they make a 7. It's the iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and then 4 hydrogen by itself. Zinc chloride, I know, is made up of Zn and Cl. What's the easy one. What's the charge on chlorine? In group 7, everybody in group 7, how much?
-1.
-1. And then George, the periodic table that I gave you, if you find chlorine, which is on the right-hand side, and you go straight up, you should see a -1 on top of it. Okay? Zinc, even though it's a transition metal, it doesn't get a Roman numeral because zinc is always what charge, plus how much? You have to look on your periodic table because I know you guys didn't memorize it. What's the charge you put inside zinc, plus how much? Aluminum's always +3, silver's always +1, cadmium's always +2. What's the charge you put in the zinc box?
2.
+2. So what I have written on my board, it's Zn plus Cl2. I'm going to put my spots in front of it to balance it. Arrow, Zn with a +2 and Cl with a -1. Do I need to write subscripts on the zinc chloride?
No.
Yes. Do we write 1s?
No.
Do we write 2s?
Yes.
We don't write 1s as subscripts. We write 1s as coefficients. So when these charges don't add to 0, you crisscross the values. Now we can balance it. Let's not do this the long way. Let's do this the way that I do it. Is zinc okay?
Yeah.
Yeah, it's 1 and 1. Is chlorine okay?
Yes.
Yes, it's 2 and 2. So if this is already balanced, what are all of the coefficients to 1s? I have people that, I think Kyle, I responded to your email this morning. I think you sent it yesterday though. If you're doing digital submissions, I am putting X's on the parts that are wrong. You should be able to see my feedback on your paper in Canvas. And if it's on paper, I'm going to pass a few things out. But y'all, if you're still not understanding when we stop, which we've had sometimes 15 to 20 minutes, that's when you'd be like, I don't understand what I'm not doing right. This is a very, very, very simple one. It's a simple one to create from the formulas or to into formula from the words, and it was already balanced. It was already fixed. So my coefficients are all 1, 1, 1 on this. It's not necessarily part of what we're doing today, but now we need to figure out, is the reaction going to happen? Like, this case it will. But the activity series are all single replacement reactions. And so a lot of this is already filled in for you. Trying to make this quicker so that when you're like, okay, this is what I need help with, or this is what I'm not understanding, I can try to help you. There is a chart on your notes on the right-hand side with an arrow that's pointing up on the right-hand side. And there is a list of a whole bunch of elements, and it's starting with lithium, if I'm remembering right. Yes. There's not a link for the notes. Let me double check. Did I not put it in there? Oh, well, here, let me put that in here real quick. Go to chemistry. Go into the 4-6 weeks. Come on, you can do it, computer. 32B. There's 32, there's 32A. You guys can see how I embed stuff into Canvas here. Hold on, those of you who are online, give me a second. I'm getting the link right now. You change it to Azel. Copy it, done. Here, paste, change it to copy. Okay. Now it will be in Canvas. While I'm in here, George, if you look, yours looks a little different than mine because it's not the student view. I don't even see the student view button anymore. It has vanished. But in general, you're going to see, like if you go remote, a link to my things. If you need a text-to-speech function, and then it's going to be the opener that we answer in class. Yesterday was a virtual lab, which you can still go and do. And then I normally put in a YouTube link. I record this class and I post it every day unless I forget. And that way, if you're not here or if you just need a refresher, you can go back to that section of the notes and you can watch it. It's not going to bother me if you look at Miss Castleberry's stuff that she does in 8th period or one of the other teachers. That's not going to bother me at all. Let me make sure I put in the link to 32B. Yeah, I didn't. So I will put that in now that I'm remembering in just a bit. But it's much easier to navigate my stuff through module. All right, so these are single replacement reactions. So you're going to have a single element and a compound on both sides of this arrow. What's a little different today is you need to figure out if the reaction is going to happen. And the way that you tell that is by where they're located on that chart on the right-hand side with the arrow. The opener was an example of what you guys need to put on in blue. You need to pay attention to your diatomics. Okay, it is iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. Most of them will say gas because chlorine, fluorine, oxygen, nitrogen, and hydrogen exist naturally in the gaseous state. If you have one of those, like today's opener, chlorine gas is not Cl, it is Cl2. But the zinc was not one of those. So zinc by itself was just Zn. It's only those 7 when they are by themselves and they end in "ene," except for the gin in oxygen, nitrogen, and hydrogen. If it doesn't end in "ine," that's when they get a 2. They end in "ine," that's when you have to look up charges and crisscross, and then who knows what that number is going to be. But you need to remember these 7. No, you either have a metal kicking out another metal, or you have a non-metal kicking out another non-metal. You have to look at the thing that's by itself on the left and then compare it to if the thing by itself on the left is a non-metal, then you need to look at the non-metal in the compound, and you're going to compare them either if they're metal and hydrogen on the larger chart, or if they're a non-metal, the iodine, bromine, chlorine, fluorine, where they're located on the periodic table. In order to kick something out, it has to be stronger than the thing in the compound. If this element by yourself is weaker than the other one that it's trying to kick out in the compound, nothing's going to happen. It's just going to bounce off of it. It's like a 60-pound kid trying to fight a 200-pound kid. They're not going to do any damage. The stronger element has to be by itself, and it's going to pick on and kick out the weaker element. For ionics, if you're building compounds, you use charges. For covalence, you are using prefixes. All of this stuff is carrying on from last semester. That's why I said if we need 2 days of review for the test on Tuesday, we will do it that way. And I know my 8th period would prefer an extra review day for the test. So I'm not going to do one thing with you guys and something different with them. We'll figure that out by tomorrow where you guys stand. If you have subscripts, if they're polyatomics, which was that other chart I gave you, George, those like SO4 sulfate, sulfates on both sides, it keeps it subscript. Other than that, if it's not related to a polyatomic, you're either using prefixes, or you're using charges to create the element. In order to know if your reaction is going to happen, I need to teach you how to use the chart. And we're going to go through a few of them, and we're going to balance again. And like I said, I'm not seeing your test Tuesday, but I'm pretty sure it's going to be primarily balancing equations, since that's what we focused on so far. So this is called the activity series of metals charts. At the very, very top, we have lithium. Okay, and at the very, very, very bottom, we have gold. At least I think that's the bottom one because I had to really shrink this to make it fit on the slide. And then somewhere else on your, I don't know where my cursor went, somewhere else, where did my cursor go? You should have this thing listed. And they're in order that you see them on the periodic table. Fluorine is at the top, and going straight down, it is fluorine, chlorine, bromine, iodine. You just need to know which section is stronger And which section is the bottom, or which one is the weaker? At the top of the list, that is the stronger element. That is essentially the bully. And in order to kick somebody out, it has to be lower than it, weaker than it on the chart. So with the nonmetals, the strongest is fluorine. Okay, with the metals, and yes, hydrogen is lumped in because it's a positive charge, not a negative charge. These guys are negatively charged. Lithium is the strongest of all of the elements. That is the bully. Lithium will kick out every other type of metal, as long as it's on that list. The weakest would be iodine. Okay, so iodine can't kick anything out. All three of these can kick out iodine. So it's the one everybody picks on. And on the metal side, that is gold. Gold is the weakest of the metals on the chart. So everything that's above gold would be able to kick gold out. And then gold would be by itself. You just have to figure out where they are. The guy that's higher up, I have no idea what it is. No idea why this keeps popping up for me. Oh, no, the guys aren't watching about plate tectonics today. There we go. You just have to compare them. If it's the lone element by itself and it's at the top, it's going to kick out the element that's in the compound. What you have to do is make sure that they're both, the nonmetals are both the metals. And like I said, hydrogen is lumped in over here because it's a plus charge, not a minus charge. Oh, well, I didn't animate that right. So to figure out if this is going to go to completion, because you guys don't have this on the right-hand side, and you guys know I can't write on my smart board and I don't even see my smart tab up there. We want to know if potassium is able to kick out copper. And I should not have had this up there already, but I didn't animate it right on my slide. So you're going to compare, you got to figure out, you're going to find the potassium, which is the letter K. The P is phosphorus. Y'all, some people, and it was in here, sodium is Na, not S. The assignment that the harder one, the longer one from Friday, I think it was Jimmy, I think you did it, and I think you turned yours in too, and you were writing S. I think maybe it was her. So two people turned it in, and you were writing S for sodium. Sodium is Na, so that wasn't done right. But potassium is here. Copper is down here. Who's the stronger element, the potassium or the copper? Who's higher up? The potassium's higher up. Higher up you go, the stronger it is. So if potassium is stronger than copper, is it going to steal its chlorine? Yes. It has to be higher up to kick out the one that's further down. So this will have a reaction that occurs. So copper was not one of those 7 elements. It's by itself. And then potassium is +1, and chlorine, second time. Chlorine is -1. So those already added up, and there are no subscripts. Once again, we do not write ones as subscripts. We write ones as coefficients. Now, if instead it was Cu plus KCl, then no reaction would have taken place. And I have an example that will show you that. But in this case, the reaction actually will occur. So I have 1 potassium, I have 1 copper, and I have 2 chlorines. We write the line directly underneath the arrow if you're doing the mathematics to balance it underneath it.
Potassium has to be like bigger than copper.
It has to be higher up. It has to be stronger. Higher up on the list is stronger for both lists, whether it's fluorine, chlorine, bromine, iodine, or it's lithium down to gold.
Does it have to be stronger than chlorine too?
No, just the copper. Metal and metal, which includes hydrogen, okay, or the fluorine, chlorine, bromine, iodine. But the list is still set up that the thing on the top is stronger and the thing on the bottom is weaker. Remember, you have to keep them in the same order. So even though potassium is over here, because we're balancing linearly, this keeps you from getting confused. Keep them so potassium, copper, chlorine. You have 1 potassium. They cannot see me pointing at the board. You've got 1 potassium, you've got 1 copper, and you've got 1 chlorine. And most of you are going to be doing things left to right, top to bottom. That's the way that I taught you. I fully expect you guys to continue to do the mathematics, and I'll have scratch paper if you need it for the test. Is 1 equal to 1 for the potassium? Yeah, that's not a problem. Is 1 equal to 1 for the copper?
Yes.
Here's the problem. Is 2 equal to 1?
Um,
No. And so that now with the coefficients that goes in front of the compound in those blanks, how do we make them the same number? Yeah, this one is going to be times 2. Animated that twice and I did not mean to. Now I know that these are the same number, but it's not the total number that goes up. It's the multiplication value. And so it's going to go in front of the compound with the chlorine. What do you have to do next before you can look at anything else? Distribute. So what else is times 2? The potassium. Now you have to start over because you changed numbers. So now, it used to be okay, but now I have 1 potassium on the left and I have 2 potassiums on the right. So how are you going to fix the reactant? Yep, we'll multiply this one by 2 also. Now, does this 2 affect anything else? No. Double check it. Is everything okay now? So what would your missing 2 values be? 1s. So if this was a test question that wanted to know what's the order of coefficients, it would be 2, 1, 1, 2. But you still, if I wrote it out in words, you still have to know how to make all the symbols the right way with the correct number of subscripts. It's like I said, this is how we started off the 6 weeks. Hell, if you don't do the formula right, everything else is wrong. Are there questions on this one? Because it's more learning how to read this chart. Next one. Oh, I didn't animate this right. Let me freeze it and fix it. Add animation. Okay, this is going to be slightly off since I didn't animate all those the right way. I didn't animate it until like literally at the end of my off period and start. So we have aluminum nitrate, which is a compound, and we have magnesium. We want to know if magnesium or aluminum is stronger first. Okay, so I have magnesium and aluminum. Magnesium is stronger, so the reaction is going to happen. Then there's no reaction, and I'm going to show you one that's like that. Now I have to, because I only have so much room on the slide. For those of you that are remote, I'm going to talk out how I got these formulas. Those of you in person can do it on the board. Aluminum is always +3. You should have put a +3 in its box. Nitrate is on that polyatomic ion chart. It is -1. I write the ones. Magnesium is not one of those 7 elements, so it's just Mg. Now we figured out that magnesium is a strong enough bully to kick out 4 aluminum. Now aluminum is also not one of those 7 elements. Magnesium is in group 2. It is +2. I've already done the information for nitrate. So we're going to have some crisscrossing going on. And I know that they're there on the board, but you still have to be able to do this process. I'm going to need 1 aluminum for every 3 nitrates. You have to put the nitrate in parentheses. Charges vanish. Let me move this over closer to it. And then I need crisscross. I need 1 magnesium for every 2 nitrates. And then you can balance it. So all I did, for those of you that are remote, is I talked through how to crisscross the charges, which you still have to be able to do. Now you're going to identify how many you have of each on both sides. I have 1 aluminum, not the inside 3 because that's part of nitrate. I have 3 nitrates on the left, no subscript. I have 1 magnesium on the left, on the right, no subscripts. That is 1 aluminum. There is a 2 outside of the nitrate, and then there's no subscript for the magnesium, so that is 1. I know they're not in that order on the right-hand side with the products, but that's the way that we're going to fix them. Is aluminum a problem?
No,
No. Is nitrate a problem?
no,
Yeah. You are multiplying both numbers up to the lowest whole number that they go into evenly. It's 6. So the left one is going to be times 2. I know the right one's going to be times 3, but I'm going to distribute this 2 first. So it doesn't jump to the nitrate. It also multiplies the aluminum by 2. I'm going to come back and have to fix that. Before I do that, I need to fix the nitrate on the right to have 6, which says 2 times what is 6? 2x equals 6. What's x? 3. This goes in front of that nitrate compound. Before I can fix the aluminum, because now it's a problem child, how many magnesiums do I have? 1 times 3 is 3. You have to just be patient and work through and make sure you distribute. Yes, A hole should be open. Now I have to fix the aluminum. So how do you fix the aluminum? You got 2 on the left and 1 on the right. Times 2. Oh, I fixed the magnesium first. Times 2 on the right. The magnesium, I had to do times 3 to make them both the same value. I should have done the green before I did the purple. But once again, this reaction only happened was because magnesium was stronger than aluminum. If I would have had my products on the reactant side, the reaction would not have occurred. And I'm pretty sure the next one is the one where the reaction does not occur. Are there questions how I did this one or how I made the compounds? I'm probably going to let you guys have a polyatomic ion chart for the test. I probably will link it in for the test. I can't link my periodic table that has all the charges on it. Might be able to just scan one in on the new copier. I haven't tried to scan stuff yet. All right, barium and fluorine. Barium fluoride, we want to see if iodine is going to be strong enough to bully fluorine. Now, fluorine is on the top of the list. So who's the strongest non-metal? Fluorine. Is iodine strong enough to kick out fluorine? No. So is any reaction going to occur at all?
No.
Negative. In order for this reaction to happen, iodine would have to be stronger than the fluorine. It is not. It is the wimpiest of all of the nonmetals. It can't kick any of them out. So we write no, and then RXN is how we do shorthand for reaction in chemistry. That's just its abbreviation.
I'm so confused. What is this one like doing on?
Right. This is stronger than chlorine. Chlorine is stronger than bromine. Bromine is stronger than iodine. As you go down, you become weaker. In order for iodine to kick out fluorine, it has to be mightier than it, and it's not. It's the weakest of them all.
Why do you do chlorine like without iodine?
No, can iodine kick out fluorine? Let me write the formula. Look. I'm not flipping it. I'm not. Barium fluoride. Barium is +2, fluorine's -1. Can iodine replace fluorine?
No.
It's not strong enough.
Well, I thought we did the first one, didn't we?
No. The thing that's by itself has to be stronger than the thing in the compound.
I think you're thinking about a different thing.
I didn't write it down wrong on your paper, Dale. No. The iodine is by itself. It's trying, we want to know if it's going to be able to replace the other non-metal in the compound, which is fluorine, which means it would have to be higher on the list. And it's not. It's at the bottom of the list. It's like I said, it's like a 60-pound kid picking a fight with a 250-pound kid. It can, I mean, it can wail on that big kid all it wants to, and the big kid's just be like, ah. Not that I'm wanting you guys to go bully little kids or anything like that. I'm not encouraging that behavior, but it's the same general concept. What is that? Do not go fight each other.
If you don't see it, like what I tell you if I do, like if you don't see it, like anything.
What?
If I tell you I'm gonna go fight someone, but you don't see it, like you don't have any proof, like when I see it in trouble.
We're supposed to report if you are saying, like, I'm going to go beat up Jimmy after school. We are supposed to report that to the principals.
I would love to see Tiffany try.
No, stop it. We are not encouraging bullying behavior in this class.
To be
Technically,
honest, I would like.
Sebastian.
I don't want to know. If we hear any kind of like threats like that, that are obviously flippant, then we are supposed to report them. We are. It's sort of like, because if something does happen and we know about it and we don't say anything about it, we're actually partially liable. Yeah, it's messed up. So it's like a cover our own tushy kind of thing. I'm just telling you the truth.
You don't say anything else.
Oh my gosh. All right, so we have solid copper iodide and it's reacting with chlorine gas. Okay, the thing by itself is the chlorine. So we want to know if it's a big enough bully to kick out the iodine. Yes, it is. Yes, it is, because it's higher on the list. So the iodine is going to switch places with the chlorine. So it'll be copper 1 chloride, and it's not a gas, it'd be iodine. Okay, so we want to know, because the chlorine is by itself, if I put the formula up here, we want to know if the chlorine is strong enough to kick out the iodine and now pair up with the copper 1. And since chlorine is higher on the list than the iodine, it's the stronger element, and it's going to kick iodine out, so it's all by itself. And it's going to make the compound with that copper 1. This is doing a whole bunch of review all at once.
Wait, so which one's picking on which one?
We want to know if the chlorine is strong enough to kick out the iodine, which means it has to be higher on the list, which it is. Okay? So copper, I'm not trying to pick on you, George. You have a lot of catching up to do in a really short period of time. Those transition metals on the periodic table, this short squatty part that don't have any pluses except for those in that one, okay, inside their box, all of these metals, not these two, and not the ones with the charges over here, but this part, all right here, there's different types, and we tell their charge with a Roman numeral. I means 1, I means 2, I means 3, IV means 4. You need to know your Roman numerals up to like 7. Copper 1 means that the Cu is +1. I'm going to just write it out on the board. I will verbalize this for those of you that are remote. Cu is +1. Iodine, when you look at the top of its row, all those get -1 in a formula. The chlorine gas always gets a 2 because it's a diatonic. The solid iodine is one of those 7. And then the copper chloride, the copper is still +1 and the chlorine's -1. So there's no subscripts because they balance out to 0. It's only when they're not the same, equal, and opposite value that we crisscross them. Then it's a matter of figuring out how many we have of each. Oh, I have it on laser still. Okay, so the coppers, they each have 1. There's no subscripts. I'm going to do the iodine next. On the left, I have 1, and on the right, I have 2. And I'm going to do the the chlorine last, and I have 2 on the left, and I have 1 on the right. This line is just put here underneath the arrow to separate the reactant, the starting material math from the product, the ending material part of the math. Is copper okay?
Yes.
Yes. Is iodine okay?
No.
No. How are we going to fix the iodine?
Times it by 2.
Times it by 2 on this side?
Yes.
That 2 goes in front of the copper iodide. So what else does it change?
Copper.
The copper. Do not forget to distribute. If there's something else in the compound, it's times that number also. I have to start back over again.
Fix copper.
Let's
Times
fix
it by
the
2.
copper. Now what does that change?
Chlorine. And
The
times that by 2.
chlorine.
And you're done.
So what's my 2 missing numbers?
1.
1s.
They were
I
not.
don't remember if I did another one or not. Like I said, it's not necessarily hard to use the chart. You just need to be shown how to use the chart.
So
Now,
what do we write for the one that like didn't work?
no reaction. If you want to abbreviate reaction as RXN, by all means do it. That's how we abbreviate reaction in chemistry. If you want to write it out as reaction, you can. Now, on this assignment paper, I'm hoping I linked it in Canvas. I'll double check that in a minute. You're really doing the bottom part. The top part, I need to teach you how to read a different chart to do the top part. So don't worry about the soluble and insoluble and the precipitate part. That's tomorrow's lesson. There's not enough time in one period to teach you how to use both charts. We're down to 10 minutes left in class. You should be able to do the bottom ones. You're comparing them side by side. It says circle the one that would place the other. So you're circling the stronger element. Who's further up on either list? Is it this one, which are the nonmetals, or is it the big long one, which are the metals plus hydrogen gas? All right, I'm going to stop my recording real quick. I know some of you have questions about yesterday's, but let me stop this one so I can upload it into Canvas.